Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me just turn on my preview screen. Okay, let me just lower down the quality of my screen. Yeah. Okay. Seems like I'm fairly visible as well as equally audible. Okay. So we would just wait for 1 or 2 minutes so that everyone joins. May I expect a quick +1? Okay. There are 20 live viewers at the moment. Can I expect at least 5 of them to reply? Just a sec. Yeah, it's time. So let's start the session now. Okay. Today we would be doing interview series of Adobe, which was scheduled today from 7 p.m. IST to 9 p.m. IST. Okay. And this ended in 8 p.m. IST. Okay. The first question was leaders in an array, and the second question was minimum X XOR A. Okay, so let's start with the first problem. We are given an array A of positive integers. Positive integers means greater than 0. Given an array means, suppose A is given with the array elements as 2, 3, 5 and 7. Okay, your task is to find the leaders in the array. Okay, so you need to find leaders in the array. So what is a leader basically? Leader is something, okay, if it is greater than or equal to the elements to its right side. Okay, so leader will be greater than or equal to the elements on right. Okay, fair enough. The rightmost element is always a leader. Why it is always a leader? Because there are no elements on the right hand side. So the most element will always be a leader. Fair enough. So let's start with the example. Okay. So first we have 2. Okay. So this would always be a leader. So we would just write 2 here. Then we would go. Okay. Let's not start from the back. Okay. Suppose the first is 16. Is 16 greater than all the elements on the right hand side, greater than or equal to? We can find 17 a counter to it. So we would just say no, it is not. Then we come to 17. Is there any element which is greater than 17? No, there is no element which is greater than 17. So we would say that yes, 17 is there. Now comes 4. Is 4 greater than the elements, greater than or equal to the elements on the right hand side? No, we have 5 which is greater than 4. So this is also not equal to. Then we have 3. Is 3 greater than or equal to the elements on the right hand side? No, it is not, because there is 5 which is greater than the current element. So we would just say this is also not equal to. Then we have 5. Is 5 greater than or equal to the elements on the right hand side? Yes, it is. So we would say yes, 5 exists. Then 2, there is no element on the right hand side, so there is nothing to compare. So we would just write 2 here itself. So what are the elements? 17, 5 and 2. Okay, so let me again say the summary of this question in Hindi. So हर एक एलिमेंट के लिए हमें ये देखना है कि उसकी राइट हैंड साइड में जो एलिमेंट्स है वो उनसे बड़े या इक्वल है कि नहीं. अगर वो राइट हैंड साइड के किसी भी एलिमेंट से अगर छोटा हो तो वो लीडर नहीं हो सकता. ओके, फेयर इनफ, दिस इज इट. ओके, लेट्स मूव फॉरवर्ड. आई होप दिस इज क्लियर. सो सपोज let's take this example only. Okay, fair enough. Yeah. So for this example, I come to this 16. So for this 16, to see if 16 is an answer or not, what are my needs at this current position? What are the needs of mine? Okay, what are the needs? Okay, so I want all the values in the right hand side. Okay, all the values in the right hand side. All values in right. ओके सारे राइट के वैल्यूज निकाल के रख दो, तो उसमें से जो बड़ा होगा उससे कंपेयर कर लेंगे. We take out all the elements on the right hand side, whichever is the maximum, we just compare it with the current element. Whatever be the value, we say if it is equal, if it is likely to be a leader or not. Fair enough. So we now know that all the values does not matter to us, only the maximum element matters to us, because we just compare it with the maximum element. This is what I told. Fair enough. This was quite intuitive. So I would just remove this and say max on right. So I just need maximum on the right hand side. To get the maximum on the right hand side, there are two things that we can do. The two things that we can do is just calculate the maximum for all element. Suppose we can go from the back and then we can create an extra array and keep the maximum element till that point. So we would come to 2. So maximum element till now is 2. So we now have 5. Is 5 greater than the last maximum element? Yes, it is greater. So maximum element now is 5. So current element is 3. Is 3 greater than the last element? No. So we would just continue with 5. Is 4 greater than 5? No. We would just say 5. Is 5 greater than 17? No, it is not. So 5 would be updated to 17. Is 16 greater than 17? No. So 17 as the maximum element remains. So this is what a max element on right. So now the comparison becomes much easier, much easier. How is it, Siddharth? I would explain you. So the comparison becomes easier by doing this. Suppose we come to 16, we look on this side. Okay, is 17 greater than the current element? Yes, so it can't be included in our answer. Is 17 greater than 5? Yes, so 17 would be included in our answer. Is 4 greater than 5? Greater than 5, this 5? No, it is not. That is why. So you can calculate this as the answer. So what is the time complexity of this particular solution? The time complexity of this particular solution is we need to traverse from the back to make this array. Okay. So one traversal is needed and the next traversal would be comparing this element with the last max element, this element with the last max element. This is what we are doing. So to do this, we are doing n comparison, and to make the array also we are doing n comparison. So the time complexity of this approach would be big O of n, because we are doing n comparison. What is n? N is the size of the array. Now we are taking extra space. Extra space, what is the size of the extra space? जितने elements array में रहेंगे, the same number of elements would be the maximum element on the right. Same thing. Fair enough. So space complexity is big O of n only. Okay. So can we do better than this or not? Okay, fair enough. So quickly tell me if till this point this is clear or not. If you have reached till this point, then this is absolutely clear, and we just need to do one little optimization and we would be done with the answer. So is this thing clear or not? Can I have a quick +2 in the chat so that I know that yes, this is clear? If you are lazy enough to write +2, just reply with a 1 in the chat. I would know that yes, so that I can differentiate between your last +1 and the recent +1. Quickly tell me if this thing is clear or not. By the way, there are 33 live viewers at the moment, and I'm trying my level best. I'm not wasting any time. I'm not hitting on the bush. I'm trying my level best. So can I please expect a like counter of at least 30 likes? Okay, fair enough. Everyone has understood. So let's move forward. Okay, so we need to keep the values till this point. Okay, we need to keep the values till this point, and now we know that the maximum is the important one. Okay, so the thing that we can do is we can traverse from the back. Okay, we can traverse from the back. If we traverse from the back, we now know that yes, this is the maximum. Okay, I would tell you how. Suppose there is a class. Okay, there is a class and there are 10 students. I start from roll number 1. I know his height is, suppose let's not take the height. Let's say that the roll number 1 has 2 girlfriends. Okay, so I know, okay, roll number 1 has 2 girlfriends. Roll number 2 has 5 girlfriends. So I know, okay, till now the maximum girlfriend that a single person has is 5. Now I move to next person, which is 3. No, 3 is not the maximum, so I would remember that 5 is the maximum till this point. Next, I would encounter 1. So I can remember the maximum. Okay, I can remember the maximum and I don't need to write 2, 5, 3, 1. I can just keep traversing and remember the maximum. And remembering the maximum is only one element, so only one variable is there, and constant are ignored in time complexity, time as well as space complexity in big O of notation. Okay, big O of n notation. That is why we can say that we are using only one variable and the space complexity would boil down to big O of 1. This is what we do. Fair enough. Now we can traverse from the back. Okay, we can traverse from the back and we can calculate our answer. Now let us move to the implementation, but let us copy this result so that we can have a dry run of this approach. Okay, let's have a dry run of this approach. Okay, this is cool. Okay, so we would start from n minus 1, that is from the back. This vector is to store answer. Store answer. Okay, now we are told that every value would be greater than 0. Greater than 0. This is where we are told. So I just took the initial maximum value as 0. Okay. Okay, fair enough. So now what we are doing is, if the current value is greater than or equal to the maximum value, we are pushing it to the vector. So let's write the vector. We are starting from the back. Is 2 greater than 0? Yes, it is. So we would write here 2. Okay. And then maximum of that into that. So it would be updated to 2. Next we are coming to 5. Is 5 greater than? Is 5 greater than 2? Yes, it is. So we would just write 5 and then update this to 5. Next we are moving to 3. Is 3 greater than 5? No, it is not. So we won't update anything. Next we would move to 4. Is 4 greater than 5? No, it is not. That is why nothing would be updated, and 4 is less than 5 also. Next there is 17. Is 17 greater than 5? Yes, it is. So first we would insert this and then we would update the value. Next we are coming to 16. Is 16 greater than 17? No, it is not. So we won't insert it and then we don't update it because the value is much greater. Okay. Now we know that the answer was 17, 5 and 2. But due to the traversal from the back, we got the inverted answer. Okay, the reverse answer. So before returning, we can just do reverse, where 17, 5 and 2. This would be converted to this and we have the answer, and then we are returning this. Okay, so let's have a break of 2 minutes where you can ask me anything, absolutely anything you like. Okay, so let's start a timer. Okay, if you understand this question, okay, you can just chill and ask me anything. If you don't understand the question, you can ask me related to this question. Whatever is fine with you. Thanks a lot, Ravi Ashwin. Thanks a lot, Anirudh. Thanks a lot, Saurav. Thanks a lot, Dum Dutch. Thanks a lot, Syed Abbas Ali. Okay, thanks a lot. Okay, now the like counter is still very less. So can you please like the video if you have not liked the video? Okay, it would be great if you just like the video. Now we would be moving forward to the next question. Okay. So tell me, समझ आ रहा है ना? Quite intuitive optimization, understood. Thanks a lot, John. Okay. समझ आ रहा है ना सबको? कुछ असुविधा होले बोलो. Okay. If you have anything to ask, you can just ask me, or else we would move forward. So quickly tell me if this thing is clear or not. Kudos to you for explaining with such example. Thanks a lot, Pritha Banerjee. Thanks a lot, Arjun. Thanks a lot, Karthik. Okay, Anuj, don't call me sir. It's absolutely fine. You can either call me Sid or either call me brother. Okay, because I'm not quite well accustomed with the sir thing. I don't feel comfortable. Okay, वो bond नहीं बन पाता है sir में. Thanks a lot, Ayushi. Okay, so let's move forward. Okay, let's move forward to the next question, which is absolutely very interesting. Okay, so let's write the question in short and we would understand it. We are given two integers a and b. Okay, so we would just write what is given. Given is a and b. Okay, the task is to find an integer x. Okay, so we would just write x and write a question mark. So we now know that yes, a and b are given and x is to find. We need to find. Okay, such that x XOR a is minimum possible. So x XOR with a should be minimum. Okay, should be minimized. And the count of set bit in x is equal to the count of set bit in b. Okay, so set bit in x is equal to set bit in b itself. Okay, fair enough. Now we know these all things. Okay, so we know that this thing is given. So before this, we now know this is a XOR thing. So let us quickly revise the truth table of XOR. Okay, so what is the truth table of XOR? To remember the truth table of XOR, we now know, okay, same, the value would be 0, and if it is different, the value would be 1. Okay, so it can be remembered this way, that if a person of same gender calls you, you don't pick up the call, that is 0. If a person of different gender calls you, you get excited and you pick up the call. Same goes for me. It's absolutely nothing different and it's absolutely fine. Okay, so 1 and 1, 1 XOR 1 would be 0 and 1 XOR 0 would be 1 itself, and 0 XOR 1 would be 1 itself, and 0 XOR 0 would be 0 itself. Okay, so this is same, that is why it is 0. This is different, that is why this is 1. This is different, that is why this is 1, and this is same, that is why it is 0. Now we know the truth table of XOR. Okay, remember this and we would be moving forward. Okay, so now we know this thing. Okay, so let us just copy this and paste it beside the example. Okay, and we would just, can we make it small? Okay, no, we can't make it small, so just let me make it in this side. Okay, fair enough. Okay, 3 and 5. So to solve any bits problem or bit mask problem, any problem, first represent the question or take the decimal as what? As binary representation. So 3's binary representation would be 1 and 1. 2 to the power 0 plus 2 to the power 1, that is 3 itself. So we now know this is correct. And 5 is equal to 1, 0, 0. This is equal to 2 to the power 2. So we now know we have 4. So we need to add 1 to it. So we would just remove the last one and write 1 to it. So now we know that A is equal to 1, 1 and B is equal to 101. Okay, we would remove this and we would make this on just beside this. Okay, fair enough. So we are given with A and B and we want to find X XOR A where it should be minimum. Okay, to first tell me, okay, we would find the next condition. This is condition 1, that it should be minimum. This is condition 2, that the number of set bits in both should be same. Okay, so first let us minimize the XOR operation. To minimize the XOR operation, let us analyze the truth table of XOR. To analyze the truth table of XOR, we know that the same thing would produce the value 0. Same thing would produce the value 0 and different would produce the value 1. Okay, now we know that. Okay, that's fine. So we know that if there is A, so if we just A 1 1 XORed with 1 1, that would become what? 0 and 0. Okay, so we now know if the same thing is XORed with the same thing, that would be 0. And that is a property of XOR, that is A XOR A is equals to 0. This is why the property. Okay, fair enough. If you don't remember this property, that is absolutely fine. So till now we have X is equals to 1, 1, Y. So this condition is fulfilled. Okay, this condition is fulfilled. But this condition is also to be respected, that if I have a girlfriend, I need to respect the decision of my mother too. We need to make both things happy. Okay, both things should be made happy. How to make both ends happy? To respect both the decision and adjusting ourselves. Fair enough, this is what we do. Now there is one more thing. Okay, there is one more concept known as MSB and there is one more concept known as LSB. What is this MSB LSB? So the numbers can be represented 0, 0, 1, 0, 0, 1, 1. What is this 0, 0, 1, 1? This means that 2 to the power 0, this means that 2 to the power 1, 2, and this goes on till 2 to the power n itself, whatever be the value. Okay, we know this thing. So this thing has less value, this thing has more value. So this can be, this side is known as most significant bit. Okay, means that this has more weightage. Okay, so when we grow old, we just try to weight who has more weightage. My mother's decision has more weightage or my girlfriend's decision has more weightage. So whatever be the thing, whatever is your priority, you can take that. Now this side has less weightage. Okay, so this is known as least significant bit. Okay, this is what is the thing. So we now know that this is the thing. Okay, we now know what is MSB, what is LSB. Fair enough. So the number of set bits in X should be equal to the number of set bits in B. And how many set bits are there in B itself? Okay, the number of set bits is this and this. So the number of set bits is how much? 2. Okay, so we now know that we have 2 bits. Okay, and the number of set bits in X is how much? 2. So we now know that the number of set bits is equal. So we can say that yes, this is also respected, this is also respected. So X is equals to 3 itself. Fair enough. Okay, let's take a different example where we would understand these things more clearly. Okay, so let me just remove this. Okay, this example doesn't provide us with any intuition. So consider taking any different example and you would get the intuition. Okay, so let's take the example of A is equals to 5 and B is equals number of set bits in, so A is equal to what? A is equals to 4 plus 1, that is 1, 0, 1. So number of this can be 2 itself. So B is equals to 1, 0 itself. So now we know that X is equal to A. So 1, 0, 1. So 1, 0, 1. So 1, 0, 1. XORed with 1, 0, 1. This is same 0, this is same 0, this is same 0. So we now know if we want to minimize and respect the first condition, we need to make X is equals to 1, 0, 1. The number of set bits in this thing is 2, but the number of set bits in this thing is 1. So we need to lower down one bit. Lower down one bit. Okay, we need to lower down the bit. Okay, so turning off which bit would still minimize this thing. So there are only two options available. First is turn off the bit on the MSB or turn on the bit on the LSB. Which is more beneficial? Okay, the thing which is more beneficial, okay, let's see. So this is turned, so this thing is turned on, this thing is turned on. So if we turn off this bit, if we just turn off this bit, then this side would become 1 and this would be 0, 0. Okay, so let's revert back. This is the first value, and if we turn off this bit, then this would be 0. So 1, 0, 1 with 1, 0, 0 would make it different. 1 same 0, 0, 0, 1, 0, 0, 1, and in this thing we have changed the MSB, and in this thing we have changed the LSB, so which is minimizing the value. So we can clearly see that if we change the MSB, we are kind of in a loss because it is having the value 4 and this is the value 1. So this is minimizing the result more. So we need to change the LSB. So till now, what all things we need and what are the requirements till this point? Okay, so let us quickly write that. The first requirement is find set bits. Find number of set bits. Okay. Now the next thing is that we need to change in LSB. Change in LSB. This is more beneficial. Okay, so quickly tell me if these two conclusions are clear or not. How are we making this conclusion? Tell me if this thing is clear or not. Please tell me. Okay, so let me just read the explanation. So my question is I get a job in a product-based companies after completing the DSA. Because I'm tier 4 college and I'm in 21 best pass out, so will I get opportunity in 22 as a fresher? Okay, so yes, I have still not completed my DSA and I am in tier 4 college, which is Netaji Subhash Engineering College, a small private college in Kolkata, and I'm currently in my 3rd year. So it's absolutely fine. You can easily crack. Okay, you can easily get a job. If you have skills, you would be prioritized. You don't need to worry about your college. If you have a good skill, don't worry about that. Just ask for a referral to anyone. He would be more than happy to give you a referral. Okay, so quickly tell me if this thing is clear or not. Okay, so we have many people replying clear to it. Okay, fair enough. So we need to find the number of set bits. To find the number of set bits, what we can do is, initially the number of set bits is equal to 0. So let us write an example, 1, 0, 1, which is equal to 5 itself. Okay, so if n is greater than 0, yes, 5 is greater than 0. So n and 1 is greater than 0, that is 1, 0, 1. If it is done with and with 1, then it is equal to 1, 0, 0. This is 0, 0. This is 1. This is equal to 1. Then C plus plus. C was initially 0. This has now been incremented to 1. Okay, fair enough. Now what are we doing is divide 5 by 2. So dividing 5 by 2 is divide 5 by 2 means 2.5. But integer division would make it 2 itself. So now the Okay, the binary representation of 2 is 1, 0. Okay, Fair enough. Now we would again give 1 0 and do a AND with 0 1, and this is equal to 0, this is also equal to 0. This is not the case, so we won't be doing anything, but we would be dividing by 2. So 2 divided by 2, 2 divided by 2 is 1 itself. Okay, so now the binary representation of 1 is what? The binary representation of 1 is 1. So 1 and with 1 is equal to 1. So yes, this is equal to greater than 0. So we would update the number of set bits to 2. So we now know that the number of set bits in 5 is equals to 2, and 1 divided by 2 is equals to 0.5, but doing the integer division of it would make it 0, and this loop would end at this point and we would return the number of set bits. So this is the function to return set bits. So the first condition that we were having is satisfied. So this condition is satisfied. Now we just need to change in LSB according to the condition. Okay, fair enough. Let us move forward. Okay, let us just see. Can you please explain the second requirement, change in LSB? Yeah, I would tell you that. Okay, so change in LSB. Okay, I would tell you at the last. Just bear with me. If you don't even understand the implementation, that's absolutely fine. I would again tell you So first we are trying to, let us first write what was the example itself. 5 and 2. Okay, so let's just write that A is equals to 5 and B is equals to 2. The binary representation of 5 is 101 and the binary representation of this is 10. Fair enough. We now know the number of set bits in X. X is equals to A. So X is equals to 101. So the number of set bits in X is equals to 2 and the number of set bits in B is equals to 1. So we have 2 minus 1, that is rem is equals to 1. That is 2 minus 1. So X is equals to 101. Now the value is initially 0. So we have a value variable which is initially 0. And then what we are doing is, if rem is greater than 0, yes, rem is greater than 0, that is it is equal to 1. Then we have position is equal to 0. Okay, we have position is equal to 0. So we would keep updating everything. Then while rem is true, that is rem is greater than 0, then what we would do is x and 1 dash dash position. This, when it is at this side, this means that it would be left shift. Okay, this is right, this is left shift. So 1 left shift by 0, 1 left shift by 0 would be 1 itself, and x and 1. So 101 is equals to 1 itself. If it is greater than 0, then we would be adding that value to the val. So now the val would become 1. Okay, fair enough. And then we are doing rem minus minus. Now rem minus minus would make it 0. Now we would again come at this position. Okay, rem is equals to 0, so this won't pass. Now x minus is equals to rem. So x was what? 101, that is 5. 5 minus 1 is equals to 4. So we now know that we have the value 4. Now why did we change in LSB? So I hope this implementation is clear. Quickly tell me if this implementation is clear. I would explain in the next slide why this thing. Suppose we have 101 or 11 and B, the number of set bits in B is 101. That is, the number of set bits in this is 2 and the number of set bits in this is 3. Okay, and we want to minimize this value after XORing. After XOR, we want to minimize this value. So turning off which bit? So now every bit has the XOR value as 1011. So every bit, if it is XORed, it would be 0000. Okay, so let us just don't write 000. Fair enough. So let us write 1011. This is equal to x. So we need to turn off any bit because the number of set bits in this is 3 and this is 2. So we need to turn off one bit. So if we turn off this bit, then 1 XOR with 0 would make it different 1, same 0, same 0, same 0. So we now know that we have the value as 1 itself. Okay, so just let me remove it. So if I change in LSB, I would be having the value 1. If I change in MSB, if I change this to this, then this is different. I would have 1. This is same 0, this is same 0, this is same 0. Okay. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. This is equal to 8. Okay. So we have 8 if we are changing the MSB. But we want to minimize, if we want to minimize the resultant value after XORing. So to minimize the resultant value after XORing, we can clearly see that if we take any example, changing the LSB is more beneficial. So which is more beneficial? We would do that because we want the minimum value, not any of the minimum value. So we would just change this MSB thing. That is why we are changing this MSB thing. Dumb Dutch, can I have a quick reply if this thing is clear or not from your side? Okay, and I would be more than happy if this is clear. Okay, so now I would again wait for the last 1 minute to see if this thing is clear or not. So 2 minutes, and we have Ask Me Anything session again. Okay, so let's wait for 2 minutes, and this session ends in 2 minutes if there is no doubts coming in. Okay, Roger Bridges, why do you write Vastek? Does it have any meaning? Okay, hookah, war, red. What is this? I don't understand this. Is it your language or is it something else? Thanks a lot. You can take more example and do it on a pen and paper if you are new to bit masking. Okay, so we have no doubts coming in, and I hope people have understood. Okay, now there is one more little announcement, that there is a free workshop going on which would go for 21 days, and it's absolutely free, and I would be taking 10 session on it on Monday, Wednesday and Friday. Okay, and in that session I would be going from point 0 to point 100. We would start from prefix sum and we would go till dynamic programming. So if you like my way of teaching and you think that I'm worthy enough to give you something, to provide you with some knowledge, and you want that to be free, then you can join that course for absolutely free. You don't have that trial thing and then you need to pay, don't have nothing. Just you need to enroll in that course, and every announcement would done in that, and I would provide you with a lot of practice question. Classes will go on Monday, Wednesday and Friday. Some would be on YouTube live, some would be on Zoom classes. So make sure you don't miss this opportunity and you are serious enough to provide value. Thanks a lot. Meet you in next Sunday. Have a nice day and all the best for your future endeavors.